Hey guys, what's up people? How are you guys doing? Hoping that all of you guys are doing good and taking good care of yourself. Welcome back to today's session. Today we'll be starting off with ICSE 10th first chapter, that is Force. My name is Anoop. Before we get started, let me introduce myself once again for all of those who are new. My name is Anoop. I'm a Master Teacher of Science here at Vedantu. A very warm welcome to all of you guys out there. So today people, we will be starting off with torque and couple, one of the very first chapters in physics for ICSE 10th, that is force. So in the days ahead we will be talking about the different topics that is related to this topic, this chapter, that is equilibrium and principle of moments. We'll also solve some numericals regarding torque and principle of moments. We'll also understand about the center of gravity and uniform circular motion, where we'll also understand about centrifugal and centripetal forces as well. So this is what the chapter contains of. So we'll be doing all of these topics as the days go by, so do not worry about it. So stay tuned for that and do not forget to subscribe for that as well. Anyways, so people, as always, we'll start off this session also with a very simple quote, and the quote for today is this: everything is theoretically impossible until it is done. Now this particular quote is something which is very close to me, because every time I listen to this quote, there is this one story that comes into my mind about the first ever steamboat. So when people made the first ever steamboat, everyone who was standing in the harbor, they were like, it's never going to work. And then when it started, people were like, it is never going to stop. So yes, nothing is ever impossible, and yes, everything will seem impossible until you don't actually put in the effort to do it. So with that said, people, let us get started with today's session. So guys, we'll start off with understanding one of the most simplest and the most basic concepts in physics, that is what exactly is force. Now by now you guys are pretty much experts in this. You know what force is. Force is what a push or pull experienced, or a push or pull on an object is what is called as force. Now we know that force can bring about a lot of change. For example, a body in the state of rest can start moving if I apply a force. For example, let's say that I have this pen, so it'll stay as it is as long as I don't apply a force. So as soon as I apply a force, it'll start moving. And we know that if the body is already in motion, if I apply a force, it'll stop as well. And we also know that force can bring about change in shape. Force can bring about change in the direction as well as speed. It can increase or decrease the speed as well. Now these are some of the concepts that you've seen in the past. But let's talk about one particular change of force that that matters in this particular topic. See, here's the thing, guys. Force can produce motion. We have already seen that. And more importantly, force can bring about two kinds of motion, either linear motion or rotational motion. Now what do I mean by this, and how does it really work? That is what we're going to start off with. So let's say this, guys. Let's say that I have two rods, all right, two metal rods. One metal rod is completely free to move. There's nothing holding it back. It is just kept on a surface. There's another rod which is actually fixed at one of the ends. So it's basically, tightened up, or it's bolted on one of the ends. Now here's the thing. Let's say that I apply a force from here. So let's say that I apply a force on both the rods over here. Now what is the kind of motion that you will see over here? For the first case, that is when it's completely free to move, the rod would basically move straight. It'll move, or it basically moves in a straight line, or translatory motion, or straight line motion. It'll move in a straight line because there's nothing holding it back. There's nothing that is fixed to it. So it'll easily move straight. Whereas the same exact force, let's say that the magnitude of force is also the same. But in the second case, you see that it would basically rotate about a particular point. So you see this, like in a door, you have a hinge. So when you apply a force, it'll rotate about that particular hinge. In the same way over here also, you see that it rotates about a particular point. It is not free to move, so it's like this. So it is fixed. So when I apply a force, it starts rotating. Instead of when it was free, when I apply force, it'll move straight. So this is the kind of motion that can bring about by the application, or when you apply some force, these are the kind of motions that you can generally see. Now, translatory motion is very simple, because whatever the direction of the force is, you see that the body moves in that particular direction in a straight line. That is what is translatory motion. Whereas when you talk about fixed motion, when a body is fixed at a point, at any of the ends, I'm talking about at any of the ends, you see that the body pivots or pivots around that particular point. So this joint or that place where it is fixed is called as a pivot or a pivot, however you want to pronounce it as. I pronounce it as pivot, so you can pronounce it as pivot or pivot. It's all the same. It's just the way of play of words, that's all. So it's pivot or pivot. So basically pivots around that particular point if it is fixed at a particular joint. Now, here's the thing, guys. Whatever force you apply, if you extend a straight line, that is called as a line of force. So wherever the force, let's say that I apply force over here, if I extend a straight line from here, this is called as a line of force. Simple. Wherever I'm applying the force, if I extend that line, that is called as a line of force. Now, here's the thing, guys. In these two cases, if you look at it, the line of force is actually passing through the fixed point or through the pivot. Now, the thing is that when the line of force is passing through the pivot, either horizontally or vertically, whichever direction it is, you see that you will not see any kind of motion, or in other words, the rod would not rotate. You can try that with your door. So just go try to push the door where it is hinged. You see that it will not move at all. So that is what I'm trying to say. Basically, when you're applying the force, and if the line of force is passing through the pivot, then you don't see any kind of motion. More importantly, it would not rotate at all because all that force is passing through the pivot. Same goes with, again, you can apply the same logic with the door. Imagine this is the door, this is the hinge. So if you apply the force this way on the wider part of the door, if you apply it, it will not move, it will not go left or right, it will just stay as it is. Now, again, example of the door, you can take that. Example is one of the most simplest and one of the most basic examples that you can think of, because it is something that you deal with every single day when you go to your room or when you walk out of the room. Everywhere you go, you have a door. So yeah, so simple example is rotation of the door. You see that here you have, this is the pivoted end, or that is the pivoted end, that is the hinges. Wherever the hinges are, that is the pivoted end, and the handle is where you generally apply the force. So basically you apply the force at the handle, and you see that the door eventually opens up when you apply that particular force. So here's the thing, people. The opening or the rotation of that particular object about that point depends on two factors. The first one is the magnitude of force. How much force are you applying? Are you just applying 20 Newton force, or are you applying 100 Newton force? Again, that definitely matters. The more force you apply, the basically more easier it gets for you to rotate it. But there's another factor also that it depends on. That is the perpendicular distance from the pivoted end to the application of the line of force. So what I'm trying to say is that, see people, you're applying a force over here. All right. So when you apply a force on the door handle, the door opens up. So you apply the force over here. Now, what is the distance from the fixed end, this end? Let me just use another color so we can differentiate it. So from what is the distance from this end to this end, wherever is the force applied? That also matters. Perpendicular distance. What is perpendicular distance? 90 degrees. So whatever is that distance, that is also considered when it comes to the ease of rotation. So the more the distance, the easier it gets to rotate it. I'll tell you that. The more the distance, the easier it gets for you to rotate to open the door, or it rotates easily about that particular fixed point. And that is something which is very, very important, guys, because there is a quantity which basically is shows a relationship between the force as well as this perpendicular distance, which, my friends, is what is called as torque. So what is torque? Torque is nothing but a combination of this, the force applied and the perpendicular distance between the line of force and the fixed point. This torque can also be called as moment of force. So basically, moment of force or a torque is the same thing. It is the exact same thing. Don't get confused in the exam if they ask you what is calculate the moment of force, or if they ask you to calculate torque. It is basically the exact same thing. So basically, torque is denoted by a symbol called as tau. This is called as tau, T-A-U. That is how it is pronounced as. So tau is equal to force into the distance. So whatever is the distance, the perpendicular distance, if you multiply that, you'll be able to get the answer for you'll be able to calculate the torque. So you can either represent the perpendicular distance as S or D. Doesn't, whatever symbol you're comfortable with, you can use that. So you'll be able to find out the perpendicular. If you were to find out the perpendicular distance and the force, you'll get basically the torque or the moment of force. So this is how you calculate it. Now again, guys, take a second. Take a screenshot of this, because these formulas are going to be super important. Again, guys, it's a humble suggestion. try to take a sheet of paper, take some color pencils, take some sketch pens if you can, write it with different colors, take a small sheet of paper, stick it somewhere you can see so that you don't remember, or you can remember it whenever you want, so you don't end up forgetting it, especially during your exams. All right. Anyways, coming back to the topic. Now, here's the thing, guys. As I was saying, the further you go from the fixed point, the greater is the torque. What do I mean by that is, see people, if you were to apply the force on the hinge, we have already seen that if you apply the force on the fixed point, where the line of force is passing through the fixed point or the pivot, you see that there's no moment at all. Or in other words, there's no torque, or there's no moment of force. If you talk about the end of the door, so you'll probably notice this, like when you apply the force in the middle of the door, you have to apply a lot more force. You have to apply a lot more force to create the same amount of torque. So whatever force you apply, imagine that you're applying the same amount of force in all the four scenarios. In the third case, where you're applying the force in the middle, there the torque would be less. So the door would open much more slowly. Whereas if you talk about the force applied at the end of the door, as soon as you push it, basically if you were to apply the force over here, it would immediately open, because the torque is, there's a lot of torque created. If you were to apply a force in the middle, the torque created is a little less, or it's half of it. And if you apply the force over here, or at the fixed point, you see that the torque is 0. Now I want all of you to try this out and let me know in the comment section below if it really works or not. So do try it out. This is applied physics, so do try it out and apply it in your real life and let me know if it works out or not. All right. Anyways, now to define torque, guys, what is torque? Torque is nothing but the product of force and the perpendicular distance between the line of force, wherever you're applying the force, and the pivoted end or the fixed end. And the SI unit of torque is Newton meter, because torque, again, if you write down the formula, it's force into distance. So SI unit of force is Newton, and the SI unit of distance is meter, so it'll be Newton meter. If we talk about the CG's unit, it'll be dyne centimeter. As simple as that, people. So I hope you guys understood this. What is torque? Once again, it is nothing but the product of force applied and the perpendicular distance between the line of force and the pivoted or the fixed end. As simple as that, guys. All right, so now that you've understood what is torque, so that completes pretty much half of the topic. Let's do some questions based on it, some problems and some little questions, and then we'll get into understanding the next topic as well. All right, guys. So hope you guys are excited for this day. Again, guys, I want all of you guys to try out each and every question. Type it out in the comment section below. Take a second. It's okay. Pause the video for a second. Write down, take a sheet of paper and a pen. Write down the answer, and it's all MCQ based, so you don't have to write. It's not a 5-mark question, 10-mark question and all that. So these are very small, simple, direct calculation questions. So just write down what the answer is, A, B, C, or D, in the comment section below. I really want to see you guys working it out, because there's no point in just watching the videos. You have to actually work it as well. Again, the first code that we started off with, everything seems impossible as long as it's not done. So yes, please do it. All right, here's the question, guys. A body is pivoted at a point. A force of 20 Newton is applied at a distance of 40 centimeter from the pivot. Calculate the moment of force or torque about that point. Is it 6 Newton meter, 8 Newton meter, 3 Newton meter, or 4 Newton meter? I'll repeat the question again. A body is pivoted at a point. A force of 20 Newton is applied at a distance of 40 centimeters from the pivot. Calculate the moment of force about the pivot. Is it 6 Newton meter, 8 Newton meter, 3 Newton meter, or 4 Newton meter? So just again, people, pause the video and try to do it by yourself. Let me also show you how it's done. All right. So here's the thing, guys. I know that torque or moment of force is equal to force into the distance, the perpendicular distance. So here they know that they've given me the force. Force is 20 Newton. They've also given me the distance to be 40 centimeters. Now here's the thing. I have to make sure that everything is in the same unit. So first thing first, the SI unit of torque is Newton meter, right? So I have to convert this centimeter into meters. So basically divided by 100, what will I get? I'll get it as 0.4 meters. Simple. Now multiply 20 into 0.4. So torque would be is equal to F into D. That is 0.20 into 0.4 meters. So you will get the answer to be, I think, around, if I'm not wrong, 20 into 0.4 was 8. So 8 Newton meter would be the answer. Simple, people. That's it. As simple as that. So it'll be around 8 Newton meter. Direct answer, direct substitution, No confusion whatsoever. I hope you guys got this. All right. Second question. Here we go. A nut is opened by a wrench of length 10 centimeters. If the least force required is 5 Newton, find the moment of force needed to turn the nut. You're supposed to find out the length is given. So distance is given. They've given you the force as well. So least force means it's basically applied at the end of it. So if this is the wrench, they're applying the force at the very end, because that is where you have to apply the least amount of force. So you're supposed to find out what is the moment of force. Which these are the options: 50 Newton meter, 0.5 Newton centimeters, 5 Newton meter, or 0.5 Newton meter. Again, guys, make sure that all the units are same. Then try out this question. I'm pretty sure that you guys would be able to give me the right answer. Anyways, nonetheless, let me just show it to you guys. So torque again is equal to force into distance, perpendicular distance. So I know the distance is 10 centimeters, and they've also given me the force to be 5 Newton. So 10 centimeters in terms of meters would be 0.1 meter divided by 100 again. So put on the values. It is 0.1, or let me just, okay, 0.1 distance into the force. So it'll give me 0.5 Newton meter. Simple as that, guys. Direct substitution, direct answer once again. So do try out the question. You'll know that the answer for this question would be option number D. As simple as that. All right, moving on to the next question, guys. Here we go. Okay, the iron door of a building is 3 meters broad. All right. It can be opened by applying a force of 100 Newton, normally at the middle of the door. All right, so if you apply a force of 100 Newton at the middle of the door, you can easily open it. Calculate the torque needed to open the door, and also the least force at its point of application to open the door. So you're supposed to calculate basically the torque needed to open the door, as well as the least force that is needed to open the door. So for the first part of the question, guys, see, here's the question. The iron door is the width of the width of the iron door is it's 3 meters. All right. So let me just draw a door for you guys. All right. The one thing that I can do properly. Yeah. So this is 3 meters. So this is 3 meters. They've given you that the width is 3 meters. You are applying a force of 100 Newton, generally in the middle. So somewhere in the middle over here, you are applying a force of 100 Newton. All right. So you're applying a force of 100 Newton. Force is equal to 100 Newton. All right. Now, you're supposed to calculate the torque needed to open the door. So calculate the torque in this case. So to find out the torque in this case, guys, again, what is the formula? The force into the perpendicular distance. Now, in this situation, you're applying the force in the middle, which means the distance. Imagine this is the fixed end or the pivoted end. This is the hinge. So imagine this is the hinge. The fixed from the fixed point, or from the pivoted end to the point where the force is applied, or the line of action of force is in the middle. So that means this distance is basically 1.5 meters, because you're applying a force in the middle. If you look at the question, you're applying a force in the middle of the door. So that distance is 1.5 meters. So put that over here. So force is 100 Newton. And the distance is 1.5 meters. So what will you get? You'll get is 150 Newton meter. Simple as that. I know that many of you guys might have got this a little confused, but this is how you do it, guys, because you're applying the force in the middle of the door. The entire width of the door is 3 meters. So middle will be about 1.5 meters. You're supposed to calculate what is the torque needed to open it. That's the first part of the question. Now, moving on to the second part of the question. This is the first part. Moving on to the second part of the question. What does the question say? You have to find out what is the least force and its point of application to on the door. So if you look at the options itself, we found out that the torque required is 150 Newton meter. So it's either option A or it's option B. Option C and D is already eliminated out. So the least force, if you have to calculate it. So what is the least force? Like I told you, as you go further and further away, the end point is the place where you'll be applying the least force. So if you talk about the least force or at the point of application, that would directly be 3 meters. Why 3 meters? If the length of the door or the width of the door itself is 3 meters, yeah, this is where, this point where that is the end of the door, the edge of the door is where basically the least amount of force is required, and more importantly, the maximum torque is also obtained. So this point because the width of the door is 3 meters, so the maximum force or the maximum torque that you can see, or the least force required to open the door, would be at the end of the door, which would directly be 3 meters. Direct, guys. It's very, very simple, because like I told you, the further you go with that, see, it's very simple. For example, if you try to open a nut and bolt with your hand, you cannot do it. You have to use a wrench, and when you use a wrench also, you can see that the person would actually apply the force at the end of the wrench, not in the middle. He'll apply the force at the end of the wrench. Why so? Because the force that is applied at the end of it, the torque would be you can apply the force required is very less, and you'll also get the maximum amount of torque or moment of force in that location. So here the right answer would be option number A, that is option number, that is the first part of the question will be 150 Newton meter, and for the second part of the question it would be option number A again, that is it'll be 3 meters, which we found out directly by using the simple logic that the least force required is at the end of it. Simple as that. Alright, anyways, with that said, moving on to the next concept right now. Hope you guys understood all of this. Again, if you have any doubts, put it in the comment section below. I'll also give you my email ID towards the end. You can send me whatever doubts you have on that. Alright, now the next concept that we're going to talk about is couple. Yeah, the couple. Yes. Now here's the thing, guys. Sometimes when, okay, let's say all these cases that we talked about, the object or that body was pivoted at one point at either of the edges, either this edge or this edge. But that is not the same. That is not, you don't have things only like that, right? You experience there are a lot of other things also that is there out there, where the hinge or that pivoted point might not be towards the end, but might be in the center. So sometimes when the pivoted point or that the fixed point is at the center, you cannot use just one force to actually open it, or you can just use one force to bring about motion. So in those cases, you have to apply, or there is basically two forces acting on it, which causes rotation. I'll tell you that. I know that you might be a little confused right now. Let me just explain it. So here's the thing, is let's take a simple steering wheel. All right. Now, when you hold a steering wheel, this is how you hold it, right? This is how you hold it. So what do? To rotate that steering wheel, you pull your right hand downwards and your left hand upwards. So basically, both of them are simultaneously moving. One is moving down and the other is moving up. This causes the steering wheel to rotate. So when so you're applying the same amount of force, but in the opposite direction. One is going downwards, the other is going upwards. So one is going down, the other is going up. So this kind of force, where you're applying two equal forces equal in magnitude but opposite in direction, that will cause our body to rotate about a point. This, my friends, is what is called as couple. What is couple? When you have two forces, equal and opposite forces, acting along the same line. So basically, when you hold it, you hold the steering wheel like this. You don't hold it like this. You don't hold one like this and the other like this. You hold it like this. So it'll be in the straight same line. You apply one force in the one direction and the other in the opposite direction, which causes the steering wheel to rotate. That is what is called as couple. So this leads to couple, or in other words, you can also write it as moment of couple. The moment that the motion, the rotation motion that is caused by it can be called as the moment of couple, or the turning effect is called as moment of couple. Now there are a lot of examples where you're using moment of couple or the couple force even without you realizing it. For example, when you want to open a lid, so what do you do when you open a lid? You hold the cap like this. So one is pushing it this way, the other is your thumb is going upwards, your index finger is going downwards. So that kind of motion would lead to a rotatory motion or a circular motion. That is what is a turning effect, which is what is called as moment of couple or couple moment, couple force. All right, so couple can provide rotation on both directions. So in the sense, what I'm trying to say is that if you talk about a steering wheel itself, you can rotate it this way also, you can rotate it this way as well. So those are called as clockwise and anti-clockwise movement. So here you have, this is called as clockwise movement. So basically when it is rotating from left to right, it is called as clockwise. When it's going from right to left, it is called as anti-clockwise moment. So you can through couple, by using couple, you can have two kinds of motion. I don't know why I'm stammering. All right, so you have two kinds of motion. You have clockwise as well as anti-clockwise moment. All right, so that is it, people. To tell you the formula to calculate moment of couple or couple, you can the formula goes like this. You have to take either of the forces, either this force or this force, any of the forces, into the distance between of them. This total distance, whatever is this distance, that would give you the moment of couple. So whatever is the force into the perpendicular distance between the two forces, that is the so in this case it will be 2d. So whatever is that distance, that will give you the moment of couple. As simple as that. Alright guys, so we'll again solve some questions, try to understand the concept in a better way. In the meantime, once again guys, let me know if you have any doubts in the comment section below. And yes, I want you guys to pause each and every question and try it out by yourself. So here's the question is, two forces each of magnitude 10 Newton act vertically upwards and downwards respectively at the 2 points A and B of a uniform rod of length 4 meters, which is pivoted at the middle point O as shown. Determine the magnitude of resultant moment of force about the pivot O. So you're supposed to find out the, again, moment of couple. They've given you the distance between the two forces, and the force, the value of the force is, the magnitude of the force is 10 Newton. So you're supposed to calculate what is the moment of couple. Simple as that, guys. The options are these: 10 Newton meter, 20 Newton meter, 30 Newton meter, or 40 Newton meters. So try it out. Again, people, pause the video, try out the question for yourself, but I'll also give you the answer in any case. So here we go, people. So moment of couple, I'll denote it as M, which is equal to the force into the distance. So I'll take it as D. So in this case, the force is 10 Newton into the distance between them is how much? They've given us, I think, 4 meters, right? So it is 4 meter. So into 4 meter, that will give me the answer as 40 Newton meter. As simple as that, guys. Direct answer. So the right answer would be option number D, which is 40 Newton meter, because again, moment of couple is equal to the force into the perpendicular distance between the two forces. Next question. Here we go. Figure shows two forces, each of magnitude 10 Newton, acting at a point A and B at a separation of 50 centimeters in opposite direction. Calculate the resultant moment of the two forces about the point A, B, and O as well, situated exactly in the middle of the two forces. So you're supposed to find out what is the moment about this point, you're supposed to find out what is the moment about this point, and also about this point. You're supposed to find out what is the resultant moment about all the three, about resultant moment at all the 3 points brought about by the two forces. All right, so it's a very simple question. Again, try this question by yourself. I'll also tell you, these are the options. First of all, you have option number A, that is 5 Newton meter, 5 Newton meter, and 2.5 Newton meter, 10 Newton meter, 5 Newton meter, and 5 Newton meter, 10, 10, 5 Newton meter, 5, 5, 5 Newton meter. Simple as that. Try it out by yourself, but in the meantime, I'll also tell you what the answer is. So this question is a little long, so I'll just basically show you. I'll write the first two part of the questions and then erase it back and then do the next part of the question as well. So to do the first one. So for A, so you're supposed to calculate what is the moment at A. You're supposed to find out what is the resultant moment at A. So for this, again, moment is equal to force into the perpendicular distance. So force is 10 Newton and the distance in this case is 50 centimeters. So convert that to meters, so that will be divided by 100. So that will give me 0.5 meters. So this will be 0 into 0.5 meters. So that will be Newton, which would give me 5 Newton meter. So that'll be the resultant moment at A. Now to find out what is the moment at B, at point B, again same thing, moment is equal to force into the perpendicular distance between the two forces. So force is equal to 10 Newton into the perpendicular distance of 0.5 meter. So that would again give me 5 Newton meter. Simple as that, guys. Again, if you have to look at the question, this is what the question is like. So you have two forces of 10 Newton acting in the opposite direction, and the distance between them is 50 centimeters. All right. Now to calculate the third part of the question. So because I don't have any space, I'll be erasing this part off. I hope you guys have taken it down or taken a note of it if you have gotten wrong. But yes, people, I expect that by now you guys would be giving me the right answers. Yeah. Anyways, moving on to the next, the third part of the question. The third part of the question is actually this. You're supposed to find out what is the moment about O. So for this question, guys, first of all, draw the diagram. All right, so I'm just going to draw the diagram. So there's one force of 10 Newton over here, another force of 10 Newton over here. This is O, exactly in the middle. So this total distance is 0. Okay, it is 0.5 meters. So this distance from here to here will be 0.25 meters. First thing. And the other distance also will be 0.25 meters itself, because it's exactly in the middle. So this is A, this is B. Now, you're supposed to calculate what is the moment at A from O. So that is what you are at O from A. That is what you're supposed to find out. You're supposed to find out what is the moment at O from A. So for the first part of the question, all right. So you're supposed to find out moment at A. Moment, one second, guys. One second. Let me erase this. All right. Okay. So once again, give me a second, people. Give me a second. So you're supposed to calculate the first part of the question, like I told you. You have to calculate what is the moment at A from O. All right. Moment at A from O. So to calculate that, what is the distance between the two points, that is between O and A? Just calculate it. It'll be 0.25. Force is 10 Newton itself, and this is 0.25 meters. So if you multiply it, you'll get it as 2.5 Newton meter, if I'm not wrong. Yeah. Now, for the second part of the question, you're supposed to calculate what is the moment at B from O. So over here, again, same formula. There's no change whatsoever. Force is 10 Newton, and the distance between from O to B is again 0.25 itself. So that would again give me 2.5 Newton meter. Now here's the thing, guys. You're supposed to calculate what is the resultant moment of the two forces in all the three cases. So here the resultant moment would be would be basically add both of these. So it'll be 0.25, that is at A as well as at B from O. So it'll be 0.25 plus, sorry, 2.5. Yeah, mistakes. Hold on. So it'll be 2.5 plus 2.5. That would give me 5 Newton meter. So that is the answer, guys. As simple as that. So if you look at it, all the three, you got it as, in all the three cases, you got it as 5 Newton meter itself. So the answer to this question would be option number D. That is 5 Newton meter at A, 5 Newton meter at B, and 5 Newton meter at O as well, because of both the forces acting on that point. Simple as that, guys. So with that said, guys, this is the homework for today. Again, you cannot walk out without a homework. This is the homework for today. The moment of force of 5 Newton about a point P is 2 Newton meter. Calculate the distance of of application of force from point P. You're supposed to find out what is the distance. They've given you the force. They've also given you the moment also. So you have to just calculate. They've given you the moment of force. They've also given you the force as well. You're just supposed to calculate the distance. Use the formula, rearrange it, get the answer, and whoever puts down the answer the fastest in the comment section below, in the next session, your name would be in the slides. So the whole world can know that you did it really fast. So if you guys enjoyed today's session, do not forget to like, share, and subscribe. I'll see you all in the next one. Take care of yourself. Stay safe. Bye bye. This is Anoop signing off for the day. Take care, guys. Bye bye. See you all.